Today I'm going to go through your Unit 2 review for calculus. The test is going to be two parts. There will be a no calculator portion and a calculator portion. So starting with the no calculator portion, these first three questions are the definition of a derivative. So the limit as h goes to 0 of f of x minus f of h over h is the definition of a derivative. So that's going to be f prime. This is the definition of a derivative at a specific point, in this case pi over 2. So it's going to be the derivative evaluated at pi over 2. Here we're getting more specific. This is still the definition of a derivative. The function is cosine and the value is pi over 2. So if my function is cosine of x, the derivative is a negative sine of x, and then we're evaluating this at pi over 2. So negative sine pi over 2. Pi over 2 is 1, so this is going to be a negative 1. Okay, so in the first unit, you would have had to go through and do this whole thing by hand. But now we know this means find the derivative evaluated at 1. So I'm just going to take this one's derivative, which is going to be 6x squared plus 15x to the negative 4. And then we're going to plug in 1. F prime of 1 is going to be 6 times 1 squared plus 15 times 1 to the negative 4, which will be 6 plus 15, which is 21. Okay, using the definition of a derivative, the limit as h goes to 0 of f of x plus h minus f of x all over h. And then we're going to plug in this for our specific equation. The limit as h goes to 0, f of x plus h means I'm going to plug in x plus h in here and here. So 2 times x plus h cubed minus 5 x plus h to the negative 3 minus f of x, which is 2x cubed minus 5x to the negative 3, all over h. Okay, again, this is just the definition of a derivative. The function we're looking at on all three of these is absolute value. And what we want to look at is at three specific locations. So 2, negative 4, and 0. The derivative is the slope. So the slope over here is negative 1. The slope over here is positive 1. So when x is 2, my slope is 1, which means my derivative is 1. At x equals negative 4, my slope is negative 1, so my derivative is negative 1. At 0, however, when we're at a corner, there is no derivative, so that's going to be undefined. Okay, now we just have a bunch of derivatives. So if f of x is this whole big thing, and we take the derivative using the power rule, you are going to get d there. We can even tell just from the first one is 12x to the 5th. That's the only one that has a 12x to the 5th. Okay, next one. Derivative of x squared is going to be 2x. So those ones are out. And then the derivative of cosine is a negative sine. So our answer is going to be D. For 10, the derivative of sine is cosine. And the derivative of secant is a positive secant tangent, so that's going to be A. So you just have to have those memorized. Okay. If f of x is x, the derivative of x is just 1. Okay, for number 12, we can use the reciprocal rule. So this is going to be a negative, and on the multiple choice, the amount of work you show is up to you. 3x plus 7 cubed, the derivative of that, over 3x plus 7 cubed squared. That's the reciprocal rule. So this will be a negative 3 times 3x plus 7 squared times 3, we have to include the chain rule, over 3x plus 7 to the 6th. Okay, so we're going to end up with a negative 9, and then this is the same thing, so this will reduce, and I'll be left with a 3x plus 7 to the 4th in the denominator. So our answer is going to be D. Okay, our next one here is going to be another quotient rule. So it's going to be a negative, the 5 will just go with us. Then we're going to have the derivative of sine of x plus cosine of x on the top over sine of x plus cosine of x squared. So that'll give me a negative 5. Derivative of sine is cosine. Derivative of cosine is a negative sine. Over that whole thing squared. The option that matches that is D. Sorry, this should have been a negative 5, which means this is positive. Okay, derivative of 2 sine x will be 2 cosine of x. This one we have to do the chain rule, because remember this is the same as sine of x squared. We've done this one a lot, but it's important. So that'll be 2 sine of x times the derivative of sine of x, which is cosine of x, which is option C here. This will also be the chain rule, but my outside function is sine, my inside function is the x squared. So this will be a cosine x squared times the derivative of the inside, 2x. So 2x cosine x squared matches. Cosine sine plus sine squared is just 1. The derivative of 1 is 0. Here, however, that's not equal to 1. So using the chain rule, this is going to be a net 2 cosine of x times a negative sine x minus 2 sine x times the derivative of sine x, which is cosine x. So this ends up being a negative 4 cosine x sine x. And antiderivative of cosine 2x. So if I was taking the derivative to get a cosine 2x, it's going to be a sine 2x. Derivative of sine is positive, so we're looking for a positive. But then to undo the 2, we have to multiply by 1/2. Okay, the next one we're going to undo the product or the power rule. So what would give us a 3x squared? That would be an x cubed. This is going to be a 3x squared plus 2x plus z. So option D. Okay, number 21 is going to be a chain rule. So we have 3 functions. We have the squared on the outside, a little bit in is sine, and then on the inside is x squared. So this will be a 2 sine x squared. Then we take the derivative of sine. So it'll be cosine x squared. And then we take the derivative of x squared, which is going to be 2x. When I simplify, it gives me 4x sine x squared, cosine x squared. Chain rule. Outside is sine, so derivative of sine is cosine. And then the derivative of sine, still cosine. Okay, for 23, suppose f of 3 is negative 1 and f prime of 3 is 5 to find the tangent line. Okay, so we have our point and we have our slope. So we're going to have y, my y value is -1, so plus 1 equals our slope, which is the derivative, which is 5 times x minus 3. And then we need to simplify it to get our answer here. So y plus 1 equals 5x minus 15. So y equals 5x minus 16, which is going to be option B. Okay, so this one we have the derivative at a point. So f prime of x, using the power rule, will be 3x squared minus 2x. Derivative of 1 over x is -1 over x squared. But if you forget that, you can turn that into an x to the -1. So then f prime of 2 is 3 times 2 squared minus 2 times 2 minus 1 over 2 squared. This is on the non-calculator, so you got to use your brain. 12 minus 4 minus 1/4. So that's going to be 8 minus 1/4, which will be 7.75. Okay, so which could be the graph of the derivative. So the derivative is the slope. The slope here is -1. The slope here is +1. So if we were to graph that, it would look like C. Similar question. Here we have a slope of, we'll call it approximately 1. Here we have a slope of 0. So this graph here has a slope of 1, and then it switches to a slope of 0. We're going to find the fourth derivative. So we're just going to continue to take derivatives using our good old-fashioned power rule. Okay, so going piece by piece, we're going to have 12x to the 5th minus 20x to the 4th plus 44x cubed minus 21x squared plus 6x plus 5. That's our first derivative. Second derivative, do it all again. 12 times 5 is 60, x to the 4th minus 80, x cubed. 44 times 3 is going to be 132, x squared. 2 times 21 is 42, x plus 6. And again, 60 times 4 is 240, x cubed. 80 times 3 is also 240. 132 times 2 is going to be 264 minus 42x. And we've got one more. 240 times 3 is going to be 720 minus 480x plus 480 plus 264 alone. If we continue taking derivatives, it's always going to be whatever the degree is plus 1. So on the 7th derivative, we will get 0. Okay, we're going to take the derivatives and name the rule. This first one, we're going to use the product rule. Okay, so the product rule, we're going to take the derivative of the first times the second plus the derivative of the second times the first. So this will be 2x cosine x minus sine x times x squared. This one's also going to be a product and the chain rule, but the main one's going to be product. So 4 tangent to x prime secant 5x cubed plus secant 5x cubed prime times 4 tangent to x. And then just take the derivatives, including the chain rule. So this will be 4, the derivative of tangent is secant squared 2x times 2 for the inside times secant 5x cubed plus the derivative of secant is secant tangent. So this is going to become secant of 5x cubed tangent 5x cubed times 15x cubed times 4 tangent to x. So when you do secant, it has to be in both parts there. Last one on this page is a quotient rule. So quotient is the derivative of the top times the bottom minus the derivative of the bottom times the top over the denominator squared. Okay, so this again is going to be the chain rule. So 2 sine of x times cosine of x times x cubed minus 3x squared sine squared x over x to the 6th. Or you can leave it as x cubed squared. Okay, here's the chain rule. Derivative of cosecant is negative cosecant cotangent. So it's going to be a negative cosecant of cotangent, cotangent of cotangent, times the derivative of the inside, which is a negative cosecant squared x. This one is product. So derivative of cosecant times cotangent plus derivative of cotangent cosecant. Derivative of cosecant is negative cosecant cotangent times the cotangent that's already there minus the derivative of cotangent is a negative cosecant squared times cosecant x, and you can leave it just like that. For the antiderivatives, what would you take the derivative of that would result in this? Well, if we have f prime is 11x to the 10th, that means my original was x to the 11th, because if I took that derivative, that's what we would get, plus c. Here, my new power, we'd add 1, so we'd get 34, and then we need to divide by that value, because if I took the derivative here, the coefficient would be 1, and that's what we're looking for. To get a sine, we take the derivative of a cosine, 9x, but then again, we have to undo that 9. So we're going to have 1/9 cosine 9x plus c. Same thing here. We're going to have my new power is going to be 10, so I need to undo that. But then I also need to undo that if I took this derivative, we'd multiply down the 10, so that would go away. But then I'd also have to multiply by the derivative of the inside. So I need to undo that by multiplying by a 1/3 plus c. Okay, the particular solution, f of x is going to be 1/3 sine 3x plus x plus c. Take the antiderivative of that, the antiderivative of that. We now have more information, so we know that 5 is equal to 1/3 sine of 0 plus 0 plus c. Well, that's going to be 0, that's going to be 0, so my c value is 5. So my particular solution is 1/3 sine 3x plus x plus 5. Okay, find the equation for the tangent line of this parametric equation at x equal, or t equals pi over 4. So I need to do two things. I need to find the point and I need to find the slope. To find this point, we're simply just going to plug in this into each of those. So x of pi over 4 is cosine 2 times pi over 4, which is pi over 2, which is going to be 0. Cosine of pi over 2 up at the top of the circle is 0. Y of pi over 4 is going to be sine 3 times pi over 4. So the y value at 3 pi over 4 is going to be a positive root 2 over 2. Next, we want to find the slope. Slope in parametric. dy dx is dy dt over dx dt. Okay, dy dt is going to be 3 cosine 3t. I just did the chain rule first. The denominator is going to be a negative 2 sine 2t. And then we're going to evaluate this at pi over 4. So we get 3 cosine 3 times pi over 4 over negative 2 sine 2 times pi over 4. So we have 3 times cosine of 3 pi over 4 is going to be a negative root 2 over 2. Sine of pi over 2 is 1, so this becomes a negative 2. And you can leave it like this, or you can simplify negative over negative is positive, and then I have 3 root 2, and then the 2's would be 4, or you can leave it just like this. Find the acceleration vector of a particle moving in the plane if the velocity vector is vxt is cosine 2t, vyt is sine 3t. These are the same two that we just did. At pi over 4, again, the same. Acceleration is the derivative of velocity. Derivative of cosine is a negative sine. So ax of pi over 4 is negative 2 sine 2 times pi over 4, which is still pi over 2. So this is negative 2. Derivative of this one is 3 cosine 3t. Evaluate that at pi over 4. Which will be 3 times a negative root 2 over 2, or negative 3 root 2 over 2. Same thing we got up here. So my velocity vector, you can write them separate or you can go ahead and combine them. Like that. Okay. H of x is f of g of x, and we're given the graphs. So h of negative 2 is going to be f of g of negative 2. G of negative 2, we go to the graph of g, is going to be 3. And f of 3 is this location here, so maybe a third or a fourth approximately. H of 3 is going to be f of g of 3. G of 3 is negative 1. And f of negative 1, 1/4, something like that. I'll accept a range of values there. Okay, what is the sign of h prime of negative 2? Well, h prime of x is going to be f prime g of x times g prime of x, just the chain rule. So h prime of negative 2 is going to be f prime g of negative 2 times g prime negative 2. G of negative 2, go here, is at 3 times g prime of negative 2. What we're interested in here is the slopes. Okay, so if I go to 3 here, that's going to have a negative slope. So this is going to be a negative value. If I go to g of negative 2, that's a horizontal line. So this is going to be a negative times 0, which is 0. Okay, and we're going to repeat that process for 3. So h prime of 3 is going to be f prime g of 3 times g prime of 3. F prime g of 3 is negative 1. And then again, we're looking at the slope of f at negative 1 and the slope of g at 3. F of negative 1 is here. That's going to have a negative slope. G of 3 is going to have a positive slope, or g prime of 3. So we have a negative times a positive, so it's going to be positive. Positive. Through an extra I. Okay. A particle moves along the x-axis so that its velocity is 3t squared minus 12t plus 9 for t greater than 0. So when is the particle at rest? That is going to be when the velocity is 0. So I'm going to factor out a 3. And then factor that trinomial. It's going to be a t minus 1 and a t minus 3. So when is it at rest? When those are 0, which is going to be t equals 1 and t equals 3. So when is the particle moving to the left? And then we're going to show when is it moving to the right. So I can do a number line chart. The two factors will affect whether it's positive or negative. Okay, so we start at 0, so I'm going to put 0 on each of these number lines. This one's going to switch at 1. This one's going to switch at 3. So it's 0 here, 0 here, 0, 0. This one's going to go from negative to positive. This one's going to go from negative to positive. So when I multiply them, negative times negative is positive, positive times negative is negative, positive times positive is positive. So when our velocity is negative, we're moving to the left. So that's going to be here between 1 and 3. When our velocity is positive, it's going to be moving to the right. So here, 0 to 1, and then when t is greater than 3. Justify our answer. V of t is less than 0, v of t is greater than 0. The acceleration is going to be the derivative of velocity. So that's going to be 6t minus 12. When is the particle slowing down and speeding up? Okay, so we need to include both velocity and acceleration. So velocity, we already have a number line chart for, is 0, 1, 3. It is positive here, negative here, positive here. The acceleration acceleration, if I set this equal to 0, is going to be 0 when t is 2. So this one's going to go negative acceleration to positive acceleration. Okay, speeding up when the sign of velocity and acceleration are the same. So here we're negative and negative, so between 1 and 2, and then past 3 we're positive and positive. So to justify your answer, V of t and A of t have the same sign. Okay, it is slowing when they have different signs. So from 0 to 1, this one's positive, this one's negative, and then from 2 to 3, this one's negative and this one's positive. Okay, this is A of t and V of t have different signs. Okay, position is going to be the antiderivative of velocity. So my velocity is 3t squared minus 12t plus 9. So if I do the antiderivative here, okay, antiderivative of this is t cubed. This is going to be minus 6t squared plus 9t plus c. Then we want to plug in my initial condition. 6 is equal to 1 cubed minus 6 times 1 squared plus 9 times 1 plus c. So 6 equals, that's a negative 5 plus 9 is 4. So my c is 2. So my position at any time is t cubed minus 6t squared plus 9t plus 2. Okay, now we want to determine the total distance traveled from 1 to 5. So looking at my velocity, from 1 to 3, the particle's moving to the left, and then from 3 to 5, it's going to be moving to the right. So I need the position at 1, I need the position where it turns around at 3, and I need the position where it ends. If we just do where it starts and where it ends, we don't necessarily get the distance traveled. Okay, sorry. At 1, we already know the position is at 6, and then for these two, we're going to need to use the equation. For 3, so this is going to be 27, this is going to be 27, this is going to be negative 54, so all of those cancel, so we're just left with 2, and the numbers won't be as mean on the test. Okay. Again, this is a little mean without a calculator, but you will get 22 here. So looking at the distance traveled, we go from 6 back to negative 2, so we travel 4, and then from 2 to 22, we go 20. So our total distance traveled is going to be 24. Okay, so now we have a graph. This is velocity. Okay, so make sure to note that. When does the body reverse directions? Okay, it's when the velocity, it's negative, then it's positive. So at t equals 2, it switches, and then it's positive to negative there at, this is 6, this is 7, so it's 6.5. When is it moving at a constant speed? So that's going to be this flat line here from 3 to 5. Okay, when is the maximum speed? Okay, so we're looking at our maximums and our minimums because this is velocity. So we're at -2 here, +2 here, -3 here, which means the speed would be 3. And that occurs when t is 9. So for the graph of the speed, we just do the absolute value of this graph. So here, instead of being at -1 or -2, we're at +2. 3 to 5. 6.5. And then this 9. So 7, 8, 9 is up here at 3. Like that. Oh. Okay, so this part gets flipped. Okay, the acceleration is going to be the derivative. Okay, so this first part of the graph, the slope is -2. So on this graph, we're going to be at -2. From here to 3, we have a slope of +2. From 3 to 5, our graph is level, so the derivative is going to be 0. Okay, from here to here, our graph is going down 5 and over 4. So just a little bit bigger than 1. Okay, and then it has a slope of +3 for that last little part of the graph. So that is the non-calculator portion of your test, and I will go on to a separate video for the calculator portion.